Alkane Nomenclature. Here is the flowchart from another video. Let's look at the characteristics of alkanes starting down here. They all conform to this formula. They're saturated, that is, only single bonds in the molecules, and they are part of the aliphatic group of hydrocarbons. There are straight chains and branches. Saturated rings belong in cycloalkanes, which are another lesson. Let's start with this molecule. The first step is to select the longest continuous chain. At first glance, you might just move across like this and count 4 carbons. However, if you start with the methyl group here and go down, you'll see there are 5. It doesn't matter where you start counting from as long as it's a continuous chain. You can start from anywhere and go in any direction. So this will establish this molecule as a pentane because of the 5 carbon atoms. Now let's consider this molecule. Counting is more straightforward here. We can start from the left. Whoops, color mistake. That 5 should be blue, not green. But we can also start from the right. In either case, this gives us a pentane. Now we have 2 substituents. We should number the chain starting at the end that's closest to the substituent or side chain. In this case, we see chlorine is closer to the left end than methyl is to the right, so we'll stay with the first numbers. Now I referred above to CH3 as methyl, so let me show the alkyl groups that you will be encountering. Here is methyl CH3 with a dash that attaches to the main chain. Ethyl with 2 carbons can be written this way or shortened to C2H5. There's propyl and butyl, but it's rare to see butyl as a substituent. We also have chlorine here. As a substituent, it's called chloro. The halogens as prefixes are shown here: fluoro, chloro, bromo, and iodo. Let's go back to our molecule here. Now we have to determine which substituent is named first. The rule is, if there are several different groups, name them in alphabetical order. Chlorine comes before methyl. We also indicate its position on the carbon chain. Chlorine is on carbon 2 and methyl is on carbon 3. The name is 2-chloro-3-methylpentane. Notice, between any number and letter, there has to be a hyphen. The hyphen joins words and numbers together. Let's consider this molecule. The numbering is clear. We have to start on the right because there's a substituent on the first carbon and none on carbon 4. So it'll be a 1-chloro and a 3-bromo, but we have to do it alphabetically. Bromo comes first, even though its number is higher. So the name is 3-bromo 1-chloro-butane, and not 1-chloro-3-bromo-butane. In this example, the numbering could start at either end at first glance. If we start on the right, the name is 2-bromo-3-chloro-butane. If we start on the left, the name is 3-bromo-2-chloro-butane. In this situation, where the alphabetical order is correct in both cases, we choose the name where the bromo has the lower number. Let's look at this one. It has 3 substituents. It looks like we could number from either end at first. Let's start on the right. You'll see why in a moment. This is a pentane, and the same group appears 3 times. If a group occurs more than once, then choose an appropriate prefix, di, tri, tetra, correct numbers, and indicate their positions on the chain. There are 2 methyls on carbon number 2 and a third on carbon 4. So we write 2,2,4-trimethyl. Numbers indicate positions on the chain, and the prefix tri indicates the number of substituents. Tri means 3, and that must agree with the 3 numbers. If we numbered it this way, we would get 2,4,4-trimethylpentane. So which one do we choose? We choose the numbering that gives the smallest numbers. And we decide this as follows. The first numbers are 2, so that's a tie. We then go to the second one and find the first point of difference. 2 is smaller than 4, so this means the first name is correct and not the second one. Let's look at this final compound. We have no choice but to start numbering from the right. Since bromo comes before chloro, we start the name with 1,2,3-tribromo. Then comes 1,2-dichloro, as well as the base name. Now, in the previous example, we went through the process of choosing the number that gives the smallest numbers. We did it by numbering each end and comparing the two names that were obtained. That method is fine, but you are now ready to solve it by a shorter version called the first point of difference. Let's look at this molecule again. We look for substituents or side chains on both of the end carbons first. Both carbons are attached to hydrogens, which don't count as substituents. So this is a tie. We then go to the next carbons and see that the left one is attached to one substituent, methyl, while the right one is attached to two of them. This is the first point of difference, and so immediately tells us to start numbering from the right side because we want those two methyls to have the lower numbers. This method avoids having to write out both names first. You should be acquainted with an organization called IUPAC. This stands for International Union of Pure and Applied Chemistry. Here is their logo. This organization in North Carolina, United States, deal with all these rules of nomenclature for organic and inorganic chemistry. It's a world body to which disputes are brought. They also deal with measurements such as atomic weight. It attempts to standardize scientific usage around the world. Pronunciations are usually IUPAC or UPAC. You can be asked to give the UPAC name or the common name. Many compounds are known by both. For example, the UPAC name is propanone, the common name is acetone. We will deal mainly with the UPAC names, but also the common names when they are well known. Here are 3 practice problems. Stop the video and try them. Here are the first 2 formulas. This bromine can be placed here or here as well. Here's the name. If you got it, good. If not, did you get this numbering? Let's find the longest continuous chain. It would be this one. The question is, where do we start numbering from? The carbon on the left or the one on the bottom right? I'll choose the left side, and we'll see the reason for this in a moment. The longest chain is 9 carbons, so that makes this a nonane. Now let's apply the method of first difference to decide which side to start numbering from. Look at these 2 carbons. How many connections are there to another carbon? We can ignore the connections to hydrogen. In each case, there's one connection to the carbon above, so there's no point of difference here. It's a tie. Now we go to the next 2 carbons, and notice that each one has connections to 2 carbon atoms, one above and one below. Again, no point of difference between these 2. We go to the 3rd carbons. Notice the carbon on the left is connected to 3 other carbons, above, below, and to the right. The other 3rd carbon is connected to only 2 carbons, above and below. So here's the first point of difference. Since the carbon on the left has more connections to other carbons than the one on the right, we start numbering the chain from the left, because this will ensure that the substituent numbers in the name will be the lowest. Since ethyl comes before methyl alphabetically, let's circle the ethyl substituents. This gives 4,5,5-triethyl. The methyl groups are on carbons 3, 6, and 6, so that's how we get the final name. Here's the final slide. Try these 2 and then return. Here's the first name. In case you didn't get it, I'll go through it. First, draw the 5 carbons for pentane. I'm showing the carbon skeleton for simplicity. Now add ethyl on carbon 4 and bromine on carbon 2. Now you see that the ethyl adds an extra carbon, so the longest chain is actually a hexane. Bromine is still on carbon 2, but now there's a methyl on carbon 4. Here's the next one. In case you didn't get this, let's write it out as a hexane chain. Now add ethyl, methyl. The longest chain, again due to the ethyl group, is 7. And so heptane. This puts methyl groups on carbons 3 and 6. This ends the video on alkane nomenclature.